Today we're going to be working on Leetcode question number 68, text justification. So we have been given an array of strings, words, and a width, max width. Format the text such that each line has exactly max width characters and is fully justified left and right. You should pack your words in a greedy approach, that is, pack as many words as you can in each line. Pad extra spaces where necessary so that each line has exactly max width characters. Extra spaces between words should be distributed as evenly as possible. If the number of spaces on a line does not divide evenly between words, the empty slot on the left will be assigned more spaces than the slots on the right. Okay, for the last line of text it should be left justified and no extra space, so we don't have to justify from with the left and right on the last line, so no extra space is inserted between the words. A word is defined as a character sequence consisting of non-space characters only. Each word's length is guaranteed to be greater than 0, and there are other requirements. So let's see the example here. The words are this is an example of text justification. Maximum width is 16. So we, as you can see that the spaces are aligned, and then it is text justified on the first two lines and not on the third line. And in this example we have a lot of words. What must be acknowledged meant shall be, and again we are basically in these examples justifying all the lines except the last one, which is left justified only. So the way we're gonna be doing it is basically we're gonna be keeping record of the spaces and the spacing between them and the extra space we have, because we are also given the maximum width. So n is the number of words, and the result which we're going to be returning is an empty array at the beginning. Both our I and j are zeros. We initialize them as zeros. The first thing we want to do is to iterate the I, starting from 0 to the number of words we have. And we want to make sure that every single time I becomes equal to j, because j is going to be may cover different number of words every time, so we don't want to do it again. So whatever words are being covered by j, we want to make I equal to that. Length is at the beginning is going to be -1, and the j is going to iterate from I, and j is going to be equal to less than n. We're going to do it until j is less than n, the total number of words, because j is kind of pointing at the number of words, and the length plus 1 plus the words of the length is less than equal to the maximum width. So basically we are deciding that do we still have enough space to put a new word in here. So whichever word we are at and the j is indicating, we want to make sure that that word length and wherever you are right now in the length, that is less than equal to the maximum width. Then we're going to change the length to, we're going to increment the length to the number of words, the length of the word j is pointing to. At the beginning the spaces is going to be equal to 1, and the extra is going to be equal to 0. Yep. So first thing we want to say is if the j is not equal to I plus 1, and the other thing we want to make sure is that the j is not equal to the n, the total number of words. If that is the case, what we are going to do is we're going to say that the spaces is the total allowed limit in that line, which is the max width, minus the length where we are right now, like how many in that line, how many have been covered. uh, Once we have the subtraction of that, we're going to be dividing it with j minus 1 minus I plus 1, and the extra is going to be very similar because uh, this is divided by, and the extra is the modulus, like basically how many spaces do we have, and it's basically a greedy approach, and how many extras is left, because extras is basically saying, okay, how much extra space it's gonna be if I put this word in there. The row is gonna be equal to that words of I. So whichever word I is pointing to, that's gonna be our row. So uh, what we're gonna be doing here is, like, we're gonna be iterating k uh, to I plus 1, and the k is less than j, and then we're gonna be incrementing k, and extras are gonna be get decremented, and we're gonna be putting in the row, we're gonna be adding the word. So we already have the word right now, whichever we want to put in. We're gonna we're gonna append that with an empty space, and we're gonna repeat uh, whatever calculated spaces and extras we had. We're gonna repeat that empty space that many times, plus the word plus the word represented by the k, as k is getting incremented. So every single time we are putting a space, repeating it, spaces plus extra if it is greater either 1 or 0 depending on the value of the extra, and we're gonna keep appending it to the row. Then we're gonna be, once we are out of that, we're gonna be appending this one single time, whatever extra spaces we have left with, we're gonna be incrementing that, and then we're gonna be pushing that whole row into the result. So we're gonna keep looping through it for the whole I and j, and then in the end we're gonna be returning the result. Looks good. Let's run it. Yeah, and let's check it for all the test cases.